All right, here we go with our live video notes. We're looking at chapter 1, section 1, integers and the coordinate plane. Now you want to take the notes that I do here now. Okay, the first two we're just checking to make sure everything worked. Now we want to make sure we're getting notes. So you should have your notebook out and take these notes just like I do them. The way I took these notes are what we call Cornell notes. I've got an essential question, which I have been writing on the board, and you'll see a line drawn here, and these are like the questions, and then this is the explanation of each of these questions, and there's examples in there. Okay, you should take the notes just like it is here. Listen to all the notes, take all the notes, pause if you have to in between so you can get the notes, and then turn it back on and get the rest of the notes, and then you can watch it again if you want. It's only going to be about 7 to 10 minutes, so let's get started. So, chapter 1, integers in the coordinate plane. The essential question here is, how do you model and find the absolute value of integers and graph points on the coordinate plane? That's what's in this section. So let's start out with how to model absolute value. Okay, when we model it, we're showing it in some kind of a mathematical way. So to use the absolute value when we are discussing real-world problems involving measurement, like length, temperature, etc., we cannot have a negative distance. So we use the negative sign to show direction, like on a thermometer, okay? The negative degrees, that's just down at the bottom. Or if we want to show negative 150 feet in depth, then we put the negative to show that it's below sea level, just like negative 5 degrees would show 5 degrees below zero. Okay, so the negative is given it a direction. So how do we evaluate the absolute value? The absolute value of a number is the distance between the number and zero. Using the number line may give a good visual for this, and I'll show you some examples at the end. But if you want to find the absolute value of negative 4, it's going to be positive 4. You want to find the absolute value of 8, it's 8, because it's 4 units here from 0 to 4, whether it's negative 4 or positive 4, and same with the 8. You're 8 units from 0. If you want to combine this into an operation here of subtraction, the absolute value of 5 minus the absolute value of 2, that becomes 5, because that's the absolute value of negative 5, minus the absolute value of 2, which is 2. 5 minus 2 is 3. Okay, so you take the absolute value first and then do the operation. All right, that's absolute value. What is the coordinate plane? The coordinate plane is formed when two number lines intersect, separating the plane into 4 regions called quadrants. You have your y-axis and your x-axis. Okay, we number the quadrants 1, 2, 3, 4 counterclockwise. Where they intersect, we call that the origin. That's the point 0, 0, the origin right there. You haven't gone, and I should also tell you that when we talk about an ordered pair, it's a pair of numbers such as 3, negative 2, and they're used to locate a point on the coordinate plane. Now that ordered pair, okay, the 3 in that ordered pair represents the x-coordinate. So it's telling you where on the x-coordinate it is. If this origin is 0, 0, to the right, like a ruler, is going to be positive. So that'd be positive 1, positive 2, positive 3. And it would be negative 1, negative 2, negative 3 going to the left. And the negative 2 represents the y-coordinate number. Okay, and that's on the y-axis. Like a thermometer. You going up, it's positive. 1, 2, 3. Down, negative 1, negative 2, negative 3, and so on. So 3, negative 2 would be 1, 2, 3, negative 2. It would be right here. Okay? So that's what an ordered pair is. It's an x, y point that describes a point on the graph. Okay, that 3, negative 2 would be in the 4th quadrant because it's down here. Anything down here is in the 4th quadrant. All right, let's look at some more here. The origin we talked about is the point of intersection of the two number lines, and its ordered pair is 0, 0. That's the starting point. So that means this point right here at the origin, that's 0, 0. Okay, the x-axis is always horizontal, flat. The y-axis is always the vertical axis. Okay, so we've got absolute value, coordinate plane. Let's take a look at some examples. Okay, in the first section here, talking about absolute value, if we wanted to show a loss, let's say you're watching a game, and in this game, you watch a game on TV, we're in football season now, and let's say there's a loss of 11 yards. How would we show that numerically? It would be minus 11. If I said that the play netted a plus 5, we would say that's a gain in the positive direction of 5 yards. Okay? If let's see, if we wanted to show a negative 32 degrees temperature, we would do that, negative 32 degrees. Okay? Graphing integers on a number line. Let's say we want to graph 11, 5, and negative 3. Okay? On the number line, I like to start with 0. So 5 is right here. 11 is going to be right here. Negative 3 will be over here on the left. Okay? You're going to graph, and just all you have to do is just highlight with a dot on the number line where they're at. Okay? And then you've got those 3 points graphed on the number line. That's the number line. It's just a ruler with positive and negative. Positive to the right, negative to the left. Okay? And then if we're going to evaluate some kind of absolute value, remember, don't take the opposite. Like the absolute value of negative 9 is 9, but the absolute value of 6 is going to be 6. How many positive units are each of these from 0? Or the simple way to think of it is, if they ask you the absolute value of the number, they always want to know the positive value. Okay, they always want to know the positive value. So your answer to an absolute is always positive. Okay? All right, let's take a look at some stuff on the coordinate plane. I like to always label. There's my x. There's my y. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Those are all going to be positive. 1, 2, 3, 4. Those are negative. This is negative. 1, 2, 3, 4. Let's say I want to plot the point P. That's at negative 2, negative 4. What that's telling me is my x is negative 2 and my y is negative 4. So there's my origin. I start here. I'm going to go 1, 2 places to the left. Then I'm going to go down 4. There's my P. What quadrant is this? Third quadrant. Okay. You want to graph the point W. And let's say W is at 5, negative 2. So my x, let's say, get a 5 out here. So there's 1, 2, 3, 4, 5 on, I missed that one up there. That's supposed to be x. And down 2. There's my W. Okay. Well, that's x-axis. I don't know what I was thinking there. Okay. That's how you would graph the points. Pretty straightforward. Remember quadrant 1, quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's always the origin, 0, 0. And you can plot points. Remember, it's always x, then y. Always go to the x, right or left, positive or negative, and then up or down, and that's your point. Okay? Hopefully this has been helpful. When you get into class, we'll look at both of these here over the next couple of days, and we'll get the work out and answer any questions that you have on it tomorrow. All right. Look forward to seeing you then. Have a good one.